The objective today is to simplify rational expressions. And we're going back to what we were doing before after we've had a review of factoring quadratic expressions where a is greater than 1. Here comes the first example, and it is 6x squared plus 7x minus 3 over 9x squared minus 1 times 3x squared plus 5x minus 2 over 2x squared plus 5x plus 3. The easiest thing in here is the 9x squared minus 1. That's a difference of two squares. So 3x plus 1, 3x minus 1. The objective isn't to study differences of two squares. We've already done that before. So that's why I'm not going through the entire explanation of how you factor that out. And what we just reviewed was this. You can try to factor that out by breaking it up as a 3x and a 2x to break up the 6x squared. And then you have a minus 3 in there. And you can try to get that from minus 1 and plus 3. You can double check it to be certain. This is going to give me 9x, and this will give me negative 2x. So together they give me 7x. So those are broken up, and you could have gotten a hint from that by looking at 3x plus 1, 3x minus 1. If you know you have 3x and 2x up top, and that you have to break this up as a 3 and a 1, this is going to be a plus 1 or a minus 1. So it's going to cancel out with one of these. So over here on this side, we have to break that one up as 3x and x. It's going to be plus minus or minus plus in the factors, but we're going to try plus 1 minus 2 and check that to see if it works. That's a minus 6x, and that's plus x. So does that work out to be a positive 5x? No, it does not. So what should it be?
It should be minus 1 plus 2.
So minus 1 and plus 2. And we'll check that one out. Minus 1 plus 2. So that is 6x, and this is minus x. So it does give me the 5x. Alright, and on the bottom we have a 2x squared to break up, so we'll do it like this. And then we have a 3 at the end, which of course is going to be 1 and 3. So let's try plus 3 and plus 1. This gives me 2x, and this is 3x. Add them together to get 5x. So it does work out. What cancels out in this expression?
2x plus 3, 2x plus 3.
There cancels out.
3x minus 1.
So we can cancel out either of them. We'll just do this one.
And
That's it. So we end up with 3x minus 1 and x plus 2 on the top. And then on the bottom, 3x plus 1 and x plus 1. But we have to figure out what this cannot be equal to. And since this is a multiplication problem, we only have to look at here and here. And here they are factored out. So we'll go down here to the bottom and do 3x plus 1 equals 0 to get 3x equals negative 1, which is a negative third. And then the same thing with this one, 3x minus 1 equals 0. 3x equals 1. X is a positive 1/3. And then here for this one, 2x plus 3 equals 0. So 2x equals a negative 3, which means x is a negative 3 over 2, or a negative 1.5. And of course we have this x plus 1, which is really simple. It's just going to be negative 1. So the values for which x cannot be equal to, this one, this one, this one, and this one. If you put them in order from least to greatest, it would be a negative 1.5 from there. And then you would have a negative 1, from here, negative 1/3 from there, and then you're left with positive 1/3. The practice problem is 4x squared minus 1 over 8x squared minus 10x plus 3 divided by 2x squared minus 17x minus 9 over 4x squared plus 5x minus 6. For this practice problem, here is how this breaks up. It should be 2x plus 1 and then 2x minus 1. On the bottom you'll have 2x minus 1 and then 4x minus 3. We're going to go ahead and multiply and flip the second fraction. Do this all at once. You have 4x minus 3 and then x plus 2 on the top, and then on the bottom you'll have 2x plus 1 and then x minus 9. The only reason I'm skipping that step is in the interest of time. So when we go back to cancel out, we have a 2x minus 1, 2x minus 1, 4x minus 3, 4x minus 3, 2x plus 1, 2x plus 1. So you should have x plus 2 over x minus 9. But for the values that x cannot be equal to, you have to go back and look at all of these here, except for the upper left. So I'm putting these out of order in the interest of time. So starting down here, you're going to have a 1/2, and then you'll have 3/4. You'll have a negative 1/2, a positive 9, another 3/4, which we already have, and then a negative 2. So if you have this and these values, come on up.